This is a production of Cornell University.
Yeah. Thank you, Marvin. Hi, everyone. Thank you so much for coming to my seminar. Today, we're going to be talking about strawberry in New York. We're going to be talking about the differences that you can see when you taste a strawberry and how they might actually be connected to the management practices as people grow them. So to start, I want to ask you all to show your hands if you've ever had a similar experience to this. Have y'all ever gone to the grocery store and you see on display this beautiful basket of strawberries? They look juicy, they're shiny, they're plump, and you're just totally sold. You take them home, sit down, take a bite, and it's sour, and it tastes maybe a little bit like cardboard, but certainly not like what you were expecting. Show of hands, anyone else? Thank you, I feel so vindicated. This is why I did my research. So, of course, there are a lot of differences in strawberry quality, and you know what to expect when you buy that basket of strawberries. You know what you're hoping to taste, and it can really disappoint. And of course, some of the reasons why those strawberries taste different from what you expect might be due to the variety being not the same, or often if you buy grocery store strawberries, especially in the winter, they had to be picked a little bit underripe because they had to make all their way from California or Florida to New York State. But there are other factors also that get lots of speculation about why they may cause differences in taste. So you hear discussions about how nutritious the soil is, how well-nourished the plant is. There's also plenty of discourse on the use and intensity of use of agricultural chemicals. So this gets played out a lot in the organic versus conventional discussion. So strawberries are, I think, fruits with a remarkable range of tasting good to tasting bad. And so this discourse over conventional versus organic can take interesting turns, both in more public spheres like Yahoo Answers, but also there are studies that are rather newsworthy and can make their way into food journals like Kitchen, where there are lots of discussions about what's going on with strawberries and does organic really make a difference. So one really interesting study examining the differences specifically between organic and conventional strawberries was Reginald et al. The study published in 2010, but the research was conducted in 2004 and 2005. So the authors found that when comparing organic versus conventional strawberries while controlling for cultivar and soil type, there's actually remarkable difference in favor of organic. They took strawberries from paired farms, where they would take one farm that was organic for 5 years or more and one farm really close to it that was conventional for 5 years or more. And they'd compare organic and conventional strawberries from these two farms. They subject the strawberries to an intense assay of phenolic tests, to sensory evaluation, and they found that really the organic strawberries outperformed in every single parameter that they tested. They were found to be juicier, they were found to be tastier by the sensory panelists, they had much higher phenolic content, and they even had a better shelf life. So those organic strawberries were really something special. And the authors concluded that the driving force behind the high quality of the organic strawberries was the remarkable higher quality of the organic farm soil. So this is a really interesting finding, but when you take a little bit of a closer look, you notice that the study was conducted in California. At the time of the study, California produced 25% of the world's strawberries, and that number has grown since then. So this study was actually conducted in the county in California that is the highest strawberry producing county in the state. So this study controlled for the soil type and for the variety, but not really for microclimate, and they didn't control for the management practices. They left that up to the growers. And one interesting thing about California growing and California strawberry growing is that they actually often use this fumigant called methyl bromide to sterilize the soil in between strawberry production years. This is not a chemical that is permitted in organic practice, but conventional farms, including the conventional farms in the study, would fumigate with methyl bromide in between every year. The organic farms, in contrast, would actually plant a cover crop, such as one that you would till in, or broccoli or cucumbers in the same land, and then plant strawberries the next year. So that's not a difference that you actually see between conventional and organic farms in New York State, because in New York State, methyl bromide is banned. So we thought that this was a very interesting study, but we wanted to see if we take a similar look at New York State, will we find similar differences? So the primary aim of our study was to help empower strawberry growers within New York State by letting them be better informed about the connections between management practices that they may choose and the resulting quality of the strawberries that they harvest. So our null hypotheses that we wanted to test, there were two of them. The first was that there's no difference in strawberry quality as you travel from farm to farm in New York State. So in this case, we define strawberry quality as the Brix, the sugar content, the titratable acidity, and also the volatile profile, or like the aromatic bouquet when you eat it. We also had the null hypothesis to test that management practices have no effect on the quality of the strawberry when you control for the soil type, for the location, and the climate associated, and also for variety. So the variety that we chose to work with is called Jewel. Jewel is a strawberry that was developed by Cornell University Agricultural Experimental Station in 1985. It quickly grew to become one of the, if not the most popular variety. According to our supplier, it is their top selling variety in New York State. Jewel is popular for several reasons. First off, visually, it's a really beautiful strawberry. You can see in the picture, they're a little bit, they have a sheen to them, they have a rich red color. They're pretty easy to spot in a field just for that luster. They also ship a little bit better because they have a little bit of a higher firmness, and they have not just a good, but an excellent flavor. So this is a mid-season variety. This means that Jewel is ripe from around the start of June to 4th of July, and it's a relatively even production berry. So throughout that season, you'll probably predictably find even amounts of strawberries in the fields. So what we're going to do today is we're going to take a look at our farm trials. We'll see what we found, and then we'll talk a little bit about our field trials, find what we found there, and then we'll sort of wrap it all up and talk about the final conclusions of our study. So for the farm trials, what we did was we wanted to get a glimpse at the variation of the Jewel strawberry as you go across New York State. So for us, the relevant regions of New York State were Eastern New York, Central / Southern Tier New York, and also Western New York. So we wanted to visit at least one farm from all of these regions for collecting our samples. So I got in my car and I drove around the state throughout strawberry season in 2018 and 2019, and I visited some farms and collected samples. In 2018, I visited 22 farms, and of those 22 farms, the next year, I came back to 10 of them to collect follow-up samples. So when I came to a farm, I'd collect 2 pints of red strawberries from their U-pick fields. Then I'd put the strawberries in a cooler and I'd transport them to plant science. Sometimes the strawberries would have to spend a night in a hotel because I was too far away to get there the same day. But as soon as I got to plant science building, I'd freeze the strawberries. And later we'd take those frozen samples, thaw them, and analyze them for their sugar content, the Brix, their titratable acidity, and also we do some volatile analyses. So I'll tell you a bit more about the volatile analysis. Basically, when you bite into a strawberry and you chew, there are hundreds of volatiles that are, airborne molecules that are released. But the thing is, you can't smell all of them. So for our study, what we wanted to do is to find out in a Jewel strawberry, what molecules are contained that have a smell that matter to the human nose. So the lab procedure for this is you want to basically mimic what goes on in your mouth for those 5 to 15 seconds after you take a bite and chew. So we'd take strawberries and we'd grind them up in a blender, and then we'd actually stop the enzymes that are released when the cells are crushed, and because you'd want them to act a little bit but not too much. So we'd add a salt to stop those enzymes, and then we put the puree into a little vial, and there's a little gap between the strawberry puree and the top of the vial, and that's called the headspace. So the tool that we used to analyze this is called solid phase microextraction gas chromatography mass spectroscopy from headspace extraction. So this instrument sends a little proboscis into the air above the strawberry puree, and it slurps up all of the volatiles present, and then it uses gas chromatography mass spectroscopy to tell you what it found. So I'm actually going to start passing these around. We found a whole lot of volatiles, but we went into the literature and we actually found the ones that have a relatively low level of concentration before they have a smell that you can actually smell. So here's the list that we found. We made a working list of 6. The first is gamma-indecalactone. When I looked up strawberry flavor, this was the first volatile that would come up most often. If you've ever had a strawberry milkshake, you've probably tasted gamma-indecalactone. It's a really cooked fruit caramely sort of take on the strawberry. And it is present in some amounts, but in milkshakes, it's often a little bit overwhelming. Then there's also linalool. Linalool is really popular in the perfume industry. About 60% of the perfumes that you try will contain linalool. It's found in a whole lot of plants. It's in basil, it's in lavender, it's in lemon. It's a lemony, florally sort of aroma. We also find isoamyl acetate, which if you've ever tasted banana-flavored Laffy Taffy, you've tasted isoamyl acetate. It's this really cloying, ripe fruit, banana-y, kind of pear-y smell. It's also so low in terms of the concentration has to be so low before you can detect it that it's actually used to test how airtight a barrier is. So if you have a container with isoamyl acetate on one side and a human on the other side, if the person can smell any isoamyl acetate, you know that the barrier is not airtight. It's also an industrial solvent. There's also hexanoic acid. This one might be a little bit surprising to see in my sweet smelling list, but it is a common plant metabolite. So hexanoic acid is this love it or hate it goat cheese barnyard sort of smell. It's got a really rich and a fatty aroma. But if you take hexanoic acid and you mix it with alcohol, it can actually form ethyl hexanoate, which is a really tropical smelling pineapple-y, slightly waxy green banana-y compound, which is an ester. And similar to ethyl hexanoate, there's also ethyl butanoate made from the sort of barnyard smelling butanoic acid, which also smells really tropical. And like it says here, it can be added to orange juice alongside with linalool to make it taste more like oranges. So here's our profile. Of course, one question that we had after creating this profile was, I was driving around New York State, I was collecting all these strawberries, and sometimes they had to spend a night in a hotel, sometimes the strawberries went straight to the freezer. On occasion, I picked the strawberries, it was really early in the season, other times it was the very last few days. So how much does the time between harvest and freezing, and also the growing degree days experienced by the plant actually affect the results that we found when we measured the volatile profile, the sugar, and the acid? We find that those factors actually don't really influence the results. So we see here that in terms of Brix and titratable acidity, we have a moderate amount of variation, around 20%, 18%. But if you look at the volatiles, you'll see that the coefficient of variation is very high, even though it's not very connected to the growing degree days or the overnight stays. So we found this to be really curious. This is all only our data from 2018, by the way. 2019 data, we still have to analyze for the volatile profile. But we did compare the Brix and the titratable acidity measures for those same 10 farms that we revisited. And here's what we found. So we find that there is a fair degree of variation in Brix within the farms between years. Some of the farms don't have that much variation. Other ones, like Farm G over here, just really had a big change in the measurement. I would like to note that these aren't absolute values. Every single one of the differences that we observed in the follow-up year was actually positive. So the strawberries were more sweet and more acidic. We're not really sure how to explain that, but it is very interesting. And it raised some questions for us about whether the microclimate might be involved. But the last thing that I want to show you from the farm data is actually this correlation matrix that we did. So in the top, we have the p-values, which shows the significance of the correlation. And at the bottom, we have the R value, which if it's positive, it shows that the correlation is positive. And if it's negative, then the correlation is negative. So we can see that the Brix and the titratable acidity are positively correlated with one another. We also see that there's this cluster of relationships between gamma and decalactone, isoamyl acetate, hexanoic acid, and ethyl hexanoate. We can also see that the strongest correlation is between ethyl hexanoate and hexanoic acid, which makes sense because one's a derivative of the other. So we see this cluster of relations. We also see that linalool and ethyl butanoate are outside of this cluster. So to conclude, what we found in our farm trials was that neither growing degree days nor the time between harvest and freezing within 1 day will affect the results that we see in the strawberries when we sample them. We find that there is variation in sugar and acid between farms and also within the same farm from year to year. We also see that there's very considerable variation between farms in terms of the volatile profile, not in terms of what volatiles are found, but in the plant's propensity to actually create the concentrations. We found that there was a relationship between gamma and decalactone, isoamyl acetate, ethyl hexanoate, and hexanoic acid, but linalool and ethyl butanoate found to act independently of Brix, titratable acidity, the other volatiles, and each other. So with these findings, we want to find out whether things that were up to the grower actually could have played a role in the results that we saw. How does the fertility of the soil affect the strawberries' behavior, or perhaps the intensity and sourcing of their agricultural chemicals? To answer some of these questions, we decided to do a farm trial within a field that we could control, or a field trial is also what it's known as. So for our field experiment, we started preparing our soil for our fields in 2017 in the autumn. We had 2 adjacent fields in East Hill Research Station, which we worked with we planted them with a cover crop for applicable plots in the fall of 2017, and we put the strawberries into the ground in May 2018. So what we wanted to do with this field trial was we wanted to replicate the common strawberry growing conditions that we could observe in New York State. So the organic would receive nitrogen in the form of compost and composted chicken manure because urea is not considered organic. Organic plots would also receive straw mulch and an incorporated cover crop into the soil. Organic pest management practices were the only ones used to control for weeds and insects and diseases. The conventional practice also mimicked common conventional practices in New York State. So the fertilizer source was urea. Conventional plots would also receive a cover crop and straw mulch, and all conventional plots would receive sprays of Devernol, which is a pre-emergent herbicide when appropriate. The pest management used was conventional. There was also this sort of treatment which we created because we were curious about the impact of the straw mulch and the cover crop. This was conventional low carbon, denoted by the letter S. So the conventional low carbon treatment is the same as conventional, gets urea, gets Devernol, additional conventional pest management, but no straw and no cover crop. So quickly, I just described this, this, and this. But then you'll see that each of these columns is broken up into 3 levels. So each of the treatments had 3 levels of intensity as well. Because even if you're an organic grower, you don't necessarily grow strawberries the same way as the other organic grower. And level of nitrogen might be one of the ways in which you differ, or the intensity of how you manage. So the low nitrogen subcategory would receive 50 pounds of nitrogen per hectare per year. The high nitrogen subcategory would receive 100 pounds of nitrogen per hectare per year, so double that. And then the intensive subcategory would receive 100 pounds of nitrogen per hectare per year, in addition to extensive agricultural chemical inputs, more so than the others. So for the organic, what that looked like was the organic strawberries would receive a mycorrhizal promoting roots dip prior to being planted, and they would also receive monthly sprays of a microbial supplement sprayed onto their foliage. For the intensive conventional low carbon and high carbon conventional, they would receive additional sprays of Sinbar, which is a fungicide, of Captan, which is a fungicide, and Sinbar, which is an herbicide. So again, these are our treatments and their 3 levels. And after we planted the strawberries in May 2018, we pinched off the flowers to promote runner and crown development. And then come summer 2019, it was time to harvest and see how our strawberries did. So right off the fields, we collected field data, which was yield and the plant density. Then we ran some lab tests to find out how the leaves were doing in terms of carbon and nitrogen. We tested the fruit's firmness, their phenolic content, the volatile analysis, and many of you here actually also participated in my taste and sniff tests. So our marketable and unmarketable yield is pretty self-explanatory. It was marketable if the berry was good enough to give to your grandmother. We would use a window just like this. We marked a 1 meter square window within the 2 central rows of every plot, and we only collected yield data from that center because we didn't want any border effects. Then also within that center plot, we measured plant density by using a 1/2 meter long and 1/4 meter wide frame, which we'd plop down in representative sections of the row and just count the established crowns. We used an Otago strawberry titrimeter refractometer to measure the Brix and the titratable acidity. And we used Fast Blue BB, which is an azo-based assay to evaluate the phenolic content. We chose Fast Blue BB because it's not reactive with ascorbic acid, which is rather high in strawberries, but is not a polyphenol. And we evaluated the firmness using a force 5 pressure meter, which I have a picture of up here. So you'll see that one strawberry will give 4 measurements because you poke it 4 times. The meter reads the newtons of force that it takes to penetrate the strawberry flesh. So here's just a little look at the various polyphenols and phenolics that exist in strawberries. I would like to stress that our phenolic evaluation didn't measure any particular one of these. It just measured the gross phenolic content within a strawberry. So we used the same approach and results from our farm trials for volatile analysis for our field trials. What we wanted to know is what are the relative levels of the volatiles that we found to be pertinent for this variety in our field strawberries, and do the differences exist in a way that actually matters to humans who taste them. So the follow-up to this volatile analysis was actually what you participated in, the taste test and the sniff test. So with the sniff test and the taste test, our main question was, is there a difference that you can smell? So the way that these worked was that volunteers would receive a total of 16 strawberries. Marvin and I selected 4 plot comparisons that we really wanted to make as a result of this research. And we would pair up the plots that we want to compare, and we'd give each volunteer a pair that could be different samples from those 2 plots or the same plot twice. And we'd have the people sniff the strawberries without looking at them and just using their noses say, do you think that these strawberries smell different enough to be different berries, or do they smell really the same and you don't think there's any difference? And so on occasion, they'd receive the same berry, but often they'd receive different berries. The taste test was exactly the same, except for you actually got to eat the berries. My guinea pigs found that the tastiest part of the strawberry was actually the top, but that's not publishable data. So what we found in the field trials was that there were significant differences in terms of total yield and in terms of foliar nitrogen content, which in turn brought about a significant difference in terms of the foliar carbon to nitrogen ratio. The percent of the total yield which was marketable was not affected by management practice, nor was the plant density or the total foliar carbon. We found that Brix, acidity, phenolic content, average berry weight, and firmness were also not connected to the management practice. So we just said that firmness was not connected to the management practice, but I did want to show you this graph where you can see how it's pretty established in strawberry literature that firmness acts on a sort of parabolic curve in terms of nitrogen. So I'll show you several graphs like this. The red bar is conventional, the green bar is conventional low carbon, and the blue bar is organic. And then treatment 1 is my low nitrogen plots, so 50 pounds of nitrogen per hectare. The 2 is the high nitrogen, so 100 pounds of nitrogen per hectare, and the 3 is the high nitrogen plus the intensive agricultural chemical applications. So you'll see that in the organic, because the release of nitrogen is relatively slow for both composted chicken manure and for compost, you actually sort of see an increase in firmness as the amount of nitrogen goes up. But with the conventional and the low carbon conventional, you see the other side of that parabola, because if nitrogen concentrations get too high, then we also know that fruits can decrease in their firmness. So this isn't a very surprising result. We can also see in total yield that the best performance by a fair amount, this is in grams, was the conventional intensive high nitrogen management. We'll see in the foliar carbon, there is a high degree of standard error, but we'll see that in the foliar nitrogen, it's very small, and the results are rather predictable because you see in the organic, because the nitrogen forms were so slow release, it doesn't seem like the foliar nitrogen was nearly as high as the plots that received urea for their nitrogen source. It's also a fun fact that a strawberry is considered deficient in nitrogen if the leaf value is below 2. So you'll see that the organic plots and the low carbon, low nitrogen plots were actually considered to be deficient in nitrogen, which is a little bit remarkable because these strawberries at this point had received 2 years worth of their nitrogen amounts. So the lowest nitrogen receiving plots had received 100 pounds per hectare at this point, and some of them were still deficient. So then in the foliar carbon to nitrogen ratio, it's reflective of the previous graph in that the organic treatment has a much higher amount of carbon relative to nitrogen than the 2 conventional treatments do. So the volatile analysis is still pending. This is the results from 2 of our 9 replicates for all of our plots. We found that in general, there is no relationship between the management style and the 6 volatiles that we decided to track. However, you'll also notice that the coefficient of variation is rather high. So it may be true that when we collect more data and have more samples, relationships between management styles will actually be unearthed, but with the current sample size that we have, we don't see any significant correlations. The taste test also reflected the results of the volatile analysis quite a bit in that people couldn't taste the difference in both cases. There wasn't a single contrast where people could do 50% or more correct identification of the different pair. However, the problem wasn't that people, it seems that the problem wasn't that the strawberries all tasted the same. It seems that the problem was that they all tasted so different from one another that even within the same treatment, people would still say they taste different even if they got the same berry. So for the contrast between organic intensive management and conventional intensive management, people were about 30% likely to give a correct answer when presented with a different pair or a same pair. For the rest of the treatments, it was 10% likely. So this seems that within the field, there's just a great deal of variation that even when we control for all of these factors, we weren't able to control the strawberries' behaviors to pass these batteries of tests. So to summarize what we found from our field data, we find that even when we control for the ripeness, for the soil type, the precipitation, and the growing degree days that the strawberries received, the only things that really are associated with the management style are the foliar nitrogen content and the total yield, and by association, the foliar carbon to nitrogen ratio. Firmness, bricks, acidity, volatile profile, phenolics, and even the taste and the smell were just not associated with management. So the economic implication of this is that for a strawberry grower in New York State, it doesn't seem that making the switch from conventional growing practices will pay off in the short term. This is a 3-year field trial, and it's possible that over a longer time, the soil can actually build up enough of these differences from the management to see results similar to what Reginald et al. Found. It very likely is due to the microbiome of the plots. But ultimately, currently, it seems that this is a cost-benefit decision up to growers. We see that there is a great deal amount of variation that we can see within a field, both just within the field strawberry plants next to each other and within the same field from year to year. We find that higher nitrogen does give higher yields, but there don't really seem to be many other payoffs in terms of quality. And we also found that really lab tools and people can detect all of this strong variation. And the management practices that we evaluated don't seem to be tied to this variation. So some follow-up questions that we'd be interested in finding out would be, what role do nutrients other than nitrogen actually play in deciding these factors? We're also curious about whether microclimate might play a role. We would like to know how the microbiome is tied to the behavior of the strawberry plants. And ultimately, we want to know if organic management does cause any impacts on flavor, how long do you have to actually do it before the results sink in and you get similar results to reginald et al. Or something else? So that's all that I have for my presentation. I have some time, so I'd like to really thank Gavin Sachs very much for letting me do so many of my STEAM analyses in your lab. Thank you, Marvin, for the Mexican food and for practicing my presentation with me so much. Greg, thank you so much for letting me do the phenolic analysis in your lab. Thank you to so many of you here who have supported me in ways that are not directly tied to my research, but just with being a grad student at Cornell. And also thank you so much, Richie, and to all the field interns for really making our research happen in the fields. And thank you all for being here today. That's all I have. I'll take any questions. Ian. Next slide. Okay. Hi.
One of your conclusions was that it does not pay to vary from the conventional approach, but isn't that not considering market preference for an organic strawberry?
That's true. That's true. It's not considering market preference, and this is only for the short term. Yes. Thank you, Don.
Well, what's the difference in price between organic strawberries and conventional? Is there a difference?
I think at the end of the day, especially if you're a U-pick grower, it depends more on the state of your fields and the time of the season. So some of the cheapest strawberries that I bought when I collected my farm trials were actually from organic farms towards the end of the season. I think if you're marketing wholesale to grocery stores, then the price point can increase a fair bit, though. Thank you.
So I've been spending part of the presentation thinking about what the right way to do a consumer liking study or consumer preference study is for something like this. And you showed some results for taste and for smell. Primarily focused on the question is there a difference? But are you aware of what the industry uses to decide if a practice or what was acceptable? Because it seems like something like this, what you care most about is the berries that be considered defective. That is, you care most about if you have 2 lots of strawberries, the average will be the exact same, but one can contain 10% disgusting berries and 10% extraordinary berries. Mm-hmm. The other was pretty homogeneous. I probably, as a producer, want something that avoids 10% disgusting berries. And so, in other words, you're trying to, because you're consuming it individually, what you care most about is not offending consumers with any given berry. But that's a speculation. Do you know what the industry does for berries for something like this? Are they most concerned about avoiding bad things in their fruit, or are they trying to achieve some sort of spectacular berries, even if it results in more heterogeneity?
So to be honest, I think Marvin might be the better answer for this question, but I can try because it's very interesting. So we had a breeder come in for one of our classes from Driscoll's who shared that her breeding projects that she's involved with now, because Driscoll's strawberries are known as really being just that bare minimum in terms of passing for acceptability. They're now trying to breed in berries specifically with an improved flavor because that's what consumers want. More than that, unfortunately, I don't know.
Yeah, I think they're shifting from avoiding the defects to be positive about the flavor because they realize that they have a bad reputation, it's not consistent, and they have to step up their game.
So when they do that, is it more important to raise all the berries equally? Or is it more important to raise the average, even if it means some of the berries are still? Because one of the things I noticed from this is there's a pretty big variation from berry to berry. Yeah. I would put it that even though it looked like a big number for collagen variance for aroma, we have a hard time detecting factors of 2 different 100% variation in aroma. We're just not that precise with our ability to smell. So that's probably as intense as 20% variation in taste in the compounds. So in terms of like, could someone reproducibly detect it? But it's still variation. People, I mean, just you pick strawberries. I have variation when I try those berries. So I can imagine Driscoll wants to up everything, but is it okay to up half their berries in a given lot and the other half don't improve?
What to ask?
Because that's what concerns me most about the organic practices versus other practices. Are you getting a bigger range? Ignore the average. If the range is bigger, that seems to be a problem, at least for supermarket strawberries.
Thank you so much, Gavin. I think you've given us
If you
a
have more
really
information,
interesting.
I'm sure we'll have time to talk. I was asking you this out of ignorance as well, because I don't know how these things are evaluated.
Thank you. Any more questions? Yes, hi, Greg.
So I'm wondering about the impact that the cultivar had in your study. So you obviously controlled for that and used Jewel, which is a very high quality strawberry. You pointed out the most popular one from that one nursery that they sell. So presumably all the sugars, the acids, the flavor volatiles are all probably very high in that variety, which may be masking subtle differences.
Oh yeah.
But I'm wondering about like other strawberry cultivars, if you think they would have, it's kind of speculation because you don't have the data, but just, if a variety was not as good as Jewel, if maybe, you had enough inkling of an idea of maybe that's where some of these practices might come to bear.
That's a wonderful question. So the first cultivar that came to mind when you asked that was actually Honey Oi. Honey Oi is a strawberry cultivar that is a little bit notorious because depending on the soil type that it is grown on, it can taste very good or very bad. So that might be a really interesting one to actually test management practices on as well. That is very true that when a cultivar can be more great because it produces more within itself, then that natural range of production might vary from variety to variety. That's really interesting. Thank you. I think I saw another hand in the back.
I did.
Hi.
That was a lovely presentation, Anya.
Thank you.
I have a question on your foliar spray. What comprised that spray?
It was Grossentia microbial supplement. So it's a proprietary blend that is very secret, but it is meant to promote better blooming and better health and sort of create a microbial sheath, I suppose, against any potential pathogens, I think through displacement, likely. So that's what we used. And we also used Myco Gold, which was a mycorrhizal supplement for the root tip at the start.
So the foliar spray is likely to be bacteria?
Yes, I believe so.
Okay, so that added with the compost, do you think that could have set up a situation where the microbes were competing, the system is competing for nitrogen against the plants?
Oh, that's so interesting. It's possible because actually if you look at some of our charts in the nitrogen content, is this, because yes, it's true. The more intensively managed organic plots actually do have, and that's within the standard error bar, yeah? So 2 times the standard error is significant. So it's just significantly lower. It is possible. Thank you, Jenny. Any more questions?
Oh, yes. Can you ask Geneva if they have any?
Oh, please. Yes, Geneva. Hi. Do you have any questions? Oh, it's mute. Hi, Geneva. Sorry, you're muted. How do I? Oh, I'm sorry. Could I please have some help?
We're okay. We don't have any
Oh,
questions.
I unmuted it. I think I unmuted it. Geneva, hi. Can you talk?
Yes. Can you hear us?
Yeah.
Yeah,
Do you
we're
have
good. We don't have any questions, but nice presentation.
Thank you. Okay, yes.
Use the foliar spray, microbial spray, and the mycorrhizal tip. And I understand that wasn't the focus of your research, but is there any research to substantiate that either or both of those are efficacious?
Efficacious? It really varies a lot. That they work, it varies. There are some studies that conclude that they do work, and it's usually the way that these sprays are created, from my understanding, is one study finds that this microbe, which is present in the soil, has a beneficial effect upon a certain crop. And then someone with an enterprising mind says, okay, well, I'll purify this colony and I'll give it to you as a spray. So normally those sprays are derived from research, but our research on this found that it doesn't seem that these sprays are very efficacious after all, in terms of nitrogen content at least, and yield. But yeah, that's an interesting question. I wish I could answer it more thoroughly. Thank you. Any more questions? Yes?
Have you considered the strawberry in greenhouse in a controlled environment compared with the field?
Oh, so I don't think there's anyone at Cornell that is currently comparing strawberries in greenhouses to strawberry in the field. I know that Jonathan Alred is doing quite a bit of research on greenhouse strawberries, but the way I understand it, they're completely different beasts. They, in fact, even ripen in the wrong direction because they ripen from the tip up, right? Whereas strawberries in the field, no, I think it's the other way. The strawberries in the field will ripen from the tip to the top, and the greenhouse strawberries will ripen from the top to the tip. So they're strange. And they're often different varieties as well, because ours actually depend on the sun exposure, whereas if you have a greenhouse, you'd probably prefer to use an ever-bearing variety that doesn't depend on the day length for production. Thank you. Okay. Thank you all so much.
This has been a production of Cornell University, on the web at cornell.edu.